Hey everyone, welcome back. Ready to dive into another fascinating topic.
I am always up for a good deep dive.
Today, things might get a little unsettling, though. We're tackling the ethics of biological warfare.
Oh, yeah, that's a heavy one for sure.
Yeah, but I think it's something we need to talk about.
Absolutely. And it's more relevant than ever, unfortunately.
We'll be using this paper as a guide, Ethical Analysis of Biological Weapons, a multifaceted dilemma.
Sounds like they hit the nail on the head with that title.
It really does. It gets into why these weapons are so terrifying and why pretty much everyone agrees they're ethically wrong.
Yeah, like this isn't just some academic debate, you know?
Right. These decisions
Mm,
about whether to develop or use these weapons, they can have a very real impact on all of us.
yeah, definitely. I think one of the things that makes bioweapons so disturbing is the sheer scale of potential harm.
Okay, so when you say scale of harm, what do you mean?
Well, we're not just talking about casualties on a battlefield, right? We're talking about the possibility of a global pandemic that could spiral out of control. Okay, so a bioweapon is scary, but why is it so different from, say, a conventional bomb?
Well, think about it this way. A bomb explodes once. It has a limited radius of destruction, right?
Yeah.
A pathogen, though, a virus or a bacteria, it can multiply exponentially.
Oh, I see what you mean. It's not a one and done kind of weapon.
Right, exactly.
Right.
It could escape a lab, mutate, spread way beyond the intended target.
You're essentially saying the damage could be uncontainable.
Yeah, and indiscriminate.
Indiscriminate, meaning
It doesn't care who it infects. Civilians, soldiers, everyone's vulnerable.
that's a major ethical issue right there.
Totally. One of the core principles of just war theory is that you should be able to distinguish between combatants and non-combatants, but with a bioweapon.
You just can't control it.
Right. The potential for what they call collateral damage is enormous.
And it's not just immediate casualties either, right?
Yeah.
What about the long-term consequences?
Exactly. We're
Right.
talking economic collapse, social unrest, a complete breakdown of trust in institutions.
It's like opening a Pandora's box.
Yeah, pretty much. Once it's out there, you can't put it back.
And this brings us to another big issue with bioweapons, doesn't it? They kind of turn the whole idea of science on its head.
Absolutely. Science is supposed to be about healing, about progress, about improving human life.
Right, the Hippocratic Oath, first, do no harm.
Exactly. But bioweapons take all that and twist it. They use scientific knowledge to create tools of destruction.
A perversion of science.
Yeah, exactly. It makes you wonder about the scientists who work on these programs, what kind of moral dilemmas they must face.
You'd have to think it would take a toll.
Oh, for sure. And it gets even more complicated when you factor in the dual-use dilemma.
Dual-use dilemma, what's that?
Okay, imagine you're a scientist researching a deadly virus. Your goal might be to understand how it spreads, maybe develop a vaccine.
Makes sense.
But that same research, it could also be used to weaponize the virus, make it even more deadly.
So it's like a double-edged sword.
Right. The knowledge itself can be used for good or for evil.
And that creates a huge ethical challenge.
Huge. So then the question becomes, how do you encourage scientific progress, but at the same time, make sure you're not giving someone the tools to build a bioweapon?
That's gotta be tough.
It is. There are groups like the Australia Group, international organizations that try to control the export of dangerous materials and technologies.
But you don't want to stifle research either.
Right. It's a constant balancing act.
Yeah.
Tough problem.
I'm starting to see why this topic is so multifaceted. It's not just about the science, it's the ethics, the politics, the potential for unintended consequences. It's all connected.
Definitely. It's all intertwined.
Speaking of politics, there's this argument that bioweapons could actually act as a deterrent. You know, that countries won't use them because they're afraid of retaliation.
Right. Like it's sort of mutually assured destruction, like with nuclear weapons.
Yeah, exactly.
Yeah.
But does that really apply here?
I'm not so sure.
Okay.
Bioweapons are notoriously difficult to detect and even harder to attribute.
Wait, so if a country were to launch a bioweapon attack, you might not even be able to prove who did it.
Exactly. It's like an invisible enemy.
So then how do you retaliate?
It becomes almost impossible.
Hmm.
And that makes the whole idea of deterrence a lot less effective.
It's a bit unsettling to think about. And it seems like this whole discussion has been very focused on the impact on humans. But what about the environment? What kind of damage could bioweapons inflict on the natural world?
Oh, that's another major concern, and it often gets overlooked. Imagine a pathogen designed to wipe out a specific crop, like wheat or rice.
Whoa. That would be devastating.
It would. We're talking about mass starvation, ecological collapse.
I'm guessing that would affect us all, not just the country that was targeted.
Absolutely. The food supply is interconnected. What happens in one part of the world affects everyone.
And it's not just about humans, right?
Mm.
Entire ecosystems could be devastated.
Exactly. It's that domino effect, one catastrophic event leading to another.
So this idea of the precautionary principle that you mentioned earlier, it becomes even more important, doesn't it?
Absolutely.
Yeah.
When the stakes are this high, we need to err on the side of caution, even if we're not 100% certain about the risks.
Okay, that makes sense. But what happens if a bioweapon is actually used? How do you hold people accountable when it's so hard to even figure out where the attack came from?
That's one of the biggest challenges. Look at the 2001 anthrax attacks in the U.S. It took years to investigate, and the perpetrator was never definitively identified.
So you could have this horrific attack, loss of life, and no justice.
It's a real possibility, unfortunately. And it highlights a major gap in global governance when it comes to bioweapons.
We've got the Biological Weapons Convention, right? The BWC. But you're saying it's not enough?
It's a good start. It bans the development, production, and stockpiling of these weapons, but it doesn't have strong enforcement mechanisms.
So it's like an honor system.
Pretty much. There's no way to independently verify whether countries are actually complying.
And that's a problem, considering what we've been talking about.
Right. It's why there have been calls to strengthen the BWC, give it more teeth,
Yeah.
But that gets into all sorts of thorny issues about national sovereignty, intellectual property rights.
It's back to that balancing act again.
Yeah, exactly.
I think it's worth looking back at history for a moment. What can we learn from past instances of bioweapons use?
Well, unfortunately, there are some truly horrific examples.
Yeah.
And they're a stark reminder of why we need to be so vigilant about preventing these weapons from falling into the wrong hands.
Give me some examples. What are we talking about here?
Well, during World War II, Japan's Unit 731 conducted brutal experiments on prisoners of war using plague, anthrax, other deadly pathogens.
Wow.
And historically, there are accounts of smallpox-infected blankets being given to indigenous populations.
It's hard to believe people would do such things.
It's a dark part of human history, for sure. But we can't forget those lessons.
Absolutely.
And even with all that vigilance, there's another layer of complexity we need to address. Defensive research.
So you're talking about developing vaccines, treatments to protect people from bioweapon attacks?
Exactly. And on the surface, that sounds perfectly ethical,
Mm-hmm.
necessary even.
Right.
But there's this slippery slope we have to consider.
What do you mean?
Well, the line between defensive research and offensive capabilities can get really blurry.
I see. So even research that's meant to protect people could potentially backfire.
That's the concern.
Yeah.
It's crucial to have really clear boundaries and strict oversight.
Otherwise, those defensive programs could inadvertently help someone develop a bioweapon.
That's the risk.
Okay, so we've talked about the real-world dangers of bioweapons, the challenges of international law and accountability, the slippery slope of defensive research. But what about the philosophical side of things? How do different ethical frameworks view the use of these weapons?
Yeah, let's get into that. There are a few major ethical theories we can look at.
I'm all ears.
So first you have utilitarianism, which is all about maximizing happiness and minimizing suffering. From a utilitarian perspective, bioweapons are a no-go. The potential for harm is just too great, no matter what the supposed benefits might be.
So utilitarianism says the bad outweighs any possible good, no question.
Pretty much. Then there's deontology.
Deontology.
Yeah, it emphasizes moral duties and rules. Deontologists would say using bioweapons is a violation of the fundamental duty to respect human life.
Okay, so it's just plain wrong, regardless of the consequences. What's the third one?
And then there's virtue ethics. It's all about developing virtuous character traits.
Okay.
So from this perspective, developing and using bioweapons reflects vices like cruelty, recklessness, a disregard for human life.
So it's not just about the act itself, it's about the kind of person you become by engaging in that kind of activity.
Exactly. And it's interesting because all these frameworks, despite their differences, they all lead to the same conclusion. Bioweapons are morally wrong.
That's pretty powerful. It seems like there's a pretty strong ethical consensus against these weapons.
Yeah. But then, of course, there's always that question of what about non-state actors? What happens when terrorist groups or other rogue actors get their hands on these weapons?
Right. That adds a whole other layer of complexity to things, doesn't it?
Oh, for sure.
And it's not just a hypothetical threat either. We've already seen what can happen when non-state actors use chemical weapons.
The Aum Shinrikyo attack in Tokyo.
Exactly. A horrific event. So how do we even begin to address that? How do we prevent that kind of thing from happening with bioweapons?
It's a tough one. It's going to require international cooperation on a whole new level. We need better intelligence sharing, stronger public health infrastructure to detect and respond to these kinds of attacks.
It sounds like we need to be thinking about biosecurity in a much broader sense.
We do. It's not just about military preparedness, it's about global health security, about recognizing that we're all interconnected, that a threat anywhere is a threat everywhere.
That's a powerful message. And it seems like a good place to pause for now. We've covered a lot of ground, but there's still so much to discuss.
There is.
But we'll pick up where we left off in our next deep dive. See you then.
See you then.
It's a lot to think about, for sure. But sometimes I find it helps to focus on the things we can actually do something about.
I agree. Like we were just talking about the importance of staying informed, right?
Yeah.
But I think one thing people don't always realize is how fear can be weaponized.
Weaponized. How so?
Well, bioweapons, they're often portrayed as this existential threat, this invisible enemy that could strike at any moment.
Oh, I see what you mean. Like, that kind of fear can be used to justify all sorts of things.
Exactly. Increased surveillance, bigger military budgets, policies that might not be popular if people weren't so afraid.
So it's not just about the actual threat itself, but how that threat is perceived and used by those in power.
That's exactly it. And that's why critical thinking is so important, We need to be able to cut through the noise, figure out what's real and what's hype.
That's easier said than done, though, right?
Mm.
Fear can really mess with our ability to think rationally.
It can. So we need to be media savvy, understand how information can be manipulated, be critical of our sources.
So it's not just about staying informed, it's about staying informed critically, making sure you're getting the full picture, not just one side of the story.
Exactly. And we also need to be aware of our own biases.
Oh, that's a good point. We all come to this issue with our own preconceptions, and those can really color how we interpret information.
Right. We all have our blind spots.
So being aware of those biases, being willing to challenge our own assumptions, that's a good starting point.
Absolutely. And, it's not just individual biases either. There are systemic biases built into institutions, media outlets, even scientific research.
So how do we account for that?
Well, the first step is acknowledging that those biases exist. Then we can start to create more inclusive spaces where different perspectives are valued.
Makes sense. More diversity of thought, more representation at the table.
Right. If the people making decisions about biosecurity actually reflect the diversity of the population they're supposed to be protecting, well, that's a good start.
It's about making sure everyone has a seat at the table.
Yeah. And it's about being willing to question the status quo, to have those uncomfortable conversations.
Speaking of uncomfortable conversations, you mentioned earlier that bioweapons are sometimes called the poor man's nuke. Can you unpack that a little?
Sure. So, nuclear weapons, they're incredibly expensive and complex to produce.
Yeah.
Bioweapons, though, they don't require those same resources. The technology is relatively simple, the materials are more readily available.
So the barrier to entry, so to speak, is a lot lower.
Exactly. And that's what makes them so appealing to terrorist groups, non-state actors, even lone wolves who might be motivated by ideology or just want to create chaos.
Okay, so how do we prevent those kinds of actors from getting their hands on this stuff?
It's a big challenge. One important step is to control the export of what they call dual-use technologies. Things that can be used for both good and bad purposes.
You talked about the Australia group earlier. Are there other organizations doing this kind of work?
Yeah, there are a number of international groups working to prevent the spread of bioweapons, the Biological Weapons Convention, the BWC.
The one we talked about before.
Right, that's one. It's definitely played a role in establishing this global norm against bioweapons.
Okay.
And there are various groups that are actively tracking potential threats, sharing intelligence, trying to promote what they call best practices for biosecurity.
So it's sort of a network of organizations and individuals working to try and stay ahead of the bad guys.
Yeah, it's a collaborative effort, for sure. And it's a constant race against time. Because as technology keeps advancing, it's getting easier and cheaper to produce bioweapons.
It's a little frightening, to be honest. It makes you wonder if we're fighting a losing battle.
I don't think so. I mean, for every person out there trying to misuse this technology, there's so many others who are working to use it for good.
That's a good point. We hear all this talk about bioterrorism and potential pandemics. It's easy to forget the amazing things biotechnology can do.
It is. There's so much potential to solve some of humanity's biggest problems. Curing diseases, feeding a growing population, fighting climate change.
Right, so it's not just about preventing the bad, it's about promoting the good.
Absolutely. And that brings us back to the importance of ethics. If we want biotechnology to be a force for good, We need those guidelines, those principles to guide us.
We talked about some of those frameworks earlier, but how do we translate those abstract ideas into concrete action?
That's a great question. It's not enough to just talk about ethics. We need to bake it into the whole process, from the initial research all the way to how those discoveries are applied.
So it's like embedding ethics into the very DNA of biotechnology.
Yeah, that's a great way to put it. Every decision, every experiment, every innovation needs to be guided by a sense of responsibility.
And that's not just on scientists, right?
Right. It's on policymakers, industry leaders, the public, everybody. We all have a stake in this.
It's a big responsibility, but it's also kind of exciting, isn't it? The fact that we have the power to influence the direction of this incredibly powerful technology.
It is exciting. And I think that's something we need to talk about more. The future of biotechnology isn't set in stone. It's something we create together.
It all comes back to those choices we make.
It does. Our choices, our actions, our commitment to using science ethically, that's what's going to determine whether biotechnology is a force for good or for harm.
That's a great point. And it leads to another question that's been on my mind. We've talked a lot about nation states, terrorist groups, but what about individuals? Could a lone wolf with enough knowledge and access to the right tools create a bioweapon?
That's a very real concern, and it's becoming more of a possibility as technology advances. It's something security experts are really worried about.
Because the tools and knowledge are becoming more accessible.
Exactly. And that means the pool of potential perpetrators is expanding. It makes it much, much harder to track potential threats and prevent attacks.
Okay, so what can we do about that? Should we be regulating access to biotechnology?
That's a really tough question. On one hand, you want to encourage innovation, right? Give scientists the freedom to explore, to push the boundaries.
Sure.
But then there's that risk that someone could use that knowledge for evil. It's that same dilemma we've been talking about. How do you balance progress with security, freedom with responsibility?
Right. Seems like every solution creates a new set of challenges.
It does. There's no easy answer. It's going to take careful thought, open dialogue,
Right.
and a lot of international cooperation.
And that's tricky, right? Because different countries have different values, different political systems, different levels of technological development. How do you find common ground on an issue as complex as biosecurity?
You're absolutely right. It's a huge challenge. But I think it starts with focusing on those shared interests.
Shared interests. Like
Right.
what?
Well, no matter where you come from, what you believe, we all have a stake in preventing a global bioweapons catastrophe. Nobody wants that. And I think that shared interest, that common ground, it can be a powerful motivator for cooperation.
So you start by finding those areas of agreement and then build from there.
Exactly. And it's not just about governments signing treaties. It's about building a global culture of biosecurity. Everyone needs to understand the risks and responsibilities involved in working with these powerful technologies.
So that brings us back to education and awareness, right? But how do we reach people who aren't already tuned into this issue? I mean, it's not exactly the most cheerful topic. It's complex, it's scary, it can feel overwhelming. How do we get people to care?
That's a great question. And it's something I struggle with too. It's tough to get people's attention when the subject is so dark. But I think there are ways to make biosecurity more relatable.
Like how? What are some ideas?
Well, storytelling is a powerful tool. Instead of just bombarding people with facts and figures, we can weave narratives that show the human impact.
Oh, so connect with people on an emotional level.
Right. And those stories can be fictional, they can be based on real events. You can even use pop culture.
Like all those zombie movies and pandemic thrillers?
Exactly. People are already fascinated by those stories. We can use those tropes, those familiar narratives, to spark conversations and get people thinking about the real-world implications.
It's about meeting people where they are, speaking a language they understand.
That's it. And we can also tap into people's natural curiosity. Biotechnology is a fascinating field, you know.
Yeah, absolutely.
There's so much amazing research going on, so much potential for good.
So focus on the positive, the potential solutions, the ways biotechnology can be used to create a better future.
Exactly. Because in the end, that's what biosecurity is all about. It's about making sure this technology is used responsibly, ethically, for the benefit of everyone.
And that's a message that everyone can get behind.
I think so.
But how do we translate that message into action?
Right.
What can people actually do to make a difference? What are those concrete steps?
Well, first, stay informed. Read articles, listen podcasts, follow experts.
Okay, knowledge is power. Check. What else?
Support organizations that are working in this space. You know, the groups that are doing the research, pushing for better policies, educating the
Or
public.
donate, volunteer, Spread the word.
Exactly. And engage with your elected officials. Make sure they know this is an issue you care about. Encourage them to support policies that strengthen international cooperation and prevent the misuse of biotechnology.
So write letters, make phone calls, all that good stuff.
Right. And remember, every voice matters. Even small actions can make a difference.
I love that. But it can be hard to believe that, this is such a huge, complex, global issue. Sometimes it feels like one person can't really change anything.
I know what you mean. It can feel overwhelming. But I really do believe in the power of collective action. If enough people speak up, if enough people demand change, those in power have to listen.
So it's about finding that balance between individual responsibility and collective action.
Exactly. And I think that's where hope lies. The future of biosecurity is not predetermined. It's something we create together through our choices, our actions, our unwavering commitment to a world where science is used ethically and for the benefit of all.
That's a powerful message. And it seems like a good place to wrap up for today.
It does.
But we'll continue this conversation in our next deep dive. Until then, stay curious, stay engaged, and stay hopeful.
Stay hopeful.
Through all these conversations about bioweapons, one thing really stands out: the need for balance.
It always comes back to that, doesn't it?
Yeah, balancing scientific progress with ethical boundaries, right? Individual freedom with the security of everyone. It's a lot to think about.
It is. And it's complex. There are no simple answers when you're dealing with these kinds of issues, especially with technology that's always changing.
It's like you're trying to hit a moving target.
Exactly.
And this whole conversation, it just highlights how global this threat really is. Like, if a bioweapon attack were to happen, it wouldn't just be one country's problem.
No, not at all. It would affect everyone. It could literally spread around the world.
Which is why it's so important for everyone to work together, right?
Absolutely. International cooperation is key. No single country can deal with this on their own, not even the most powerful ones.
Okay, that makes sense. But that seems pretty hard to pull off, doesn't it? Look at the state of the world right now. There's so much division between countries, so much mistrust. How do we even start to build the kind of trust and cooperation needed to deal with this kind of threat?
It's a huge challenge, no doubt. But I think it starts with remembering that deep down, we all want the same thing.
Which is?
To be safe.
Yeah.
To be healthy. To have a future. The threat of bioweapons, that's something that transcends national borders and political differences. It's a threat to all of humanity.
So if we focus on that, on those shared goals, maybe that can be the starting point?
I think so. And it can't just be governments talking to each other. We need scientists from different countries collaborating, researchers sharing their knowledge.
Like building a global network of experts?
Exactly.
Yeah.
Sharing information, best practices, developing relationships, those connections, that trust, it's essential, especially if something bad were to happen.
Yeah, so you can respond faster, more effectively.
Right. And those relationships, they can help prevent an isolated incident from turning into a global pandemic.
It's like, I don't know, like a global immune system, right? All these different parts working together to protect the body.
I like that. It's a good analogy. We're all connected. What affects one of us affects all of us.
Okay, so that's a good takeaway for our listeners.
Definitely.
The future of biosecurity. It's not something that's going to be decided in some secret meeting. It's a future that we're all creating together.
Every single day. Through the choices we make, the actions we take.
So stay curious, everyone. Stay engaged and stay hopeful.
Yes, stay hopeful.
We can do this. Thanks for joining us for this deep dive.